Today I'm going to review replacement reactions. There's two kinds of reactions, single replacement reactions and double replacement reactions. You are going to need your solubility chart as well as your activity series in order to follow along. Also make sure you have your notes handout to fill in the example reactions that we're going to practice together. The first one we're going to talk about is a single replacement reaction. With a single replacement reaction, we're going to have the atom of one element replacing the atoms of another element. This is simplified by the reaction here. The element A is going to go in and bump element B out. Therefore, the new compound is compound AX, and the leftover element is B. Now, one important thing to remember is we still have to maintain our positive and negative balancing each other out. So you will need to know what the charge on A is, the charge on B is, and the charge on X. Notice how in the compound BX, B must be our positively charged ion, X must be the negatively charged ion. Therefore, when A goes in and replaces B to have the compound AX, A is going to have the positive charge, X still has its negative charge. So we have to make sure that this overall compound here is neutral in the end. The picture to the right shows an example of this kind of reaction. Here we have a wire. This wire is made of copper. And this copper wire is placed in a compound. And this compound is the liquid here that it is floating in. And so what happens is the silver that is in the liquid goes and replaces the copper. So now we have floating copper, and the silver becomes the solid instead. You have to use a reactivity chart in order to determine if a reaction is going to happen or not. In this chart, you can see lithium is the most reactive, while gold is the least reactive. Therefore, gold is not going to ever react with another one of these elements above it. Metals are not always going to replace those other metals. So it's going to depend on their reactivity. We have to use this chart in order to determine if a reaction will occur or not. So a specific metal can only replace a metal that's below it. We use NR to indicate that no reaction is going to occur if the metal is not above the other metal in order for the replacement to happen. So here's an example. Let's try a few together. Will copper replace silver? So if I look at my list, I have copper right here, and I have silver. So I want to know, is copper higher than silver? Is copper going to bump the silver out? Since copper is above silver, it will bump the silver out and replace the silver. So the answer to the first one is yes, there will be a reaction. How about the second one? Will silver replace copper if you place it in a copper solution? So will the silver, which is located right here, will it bump the copper out of place? The answer is no. Silver is not higher up on the activity series. It doesn't have the energy, the ability to bump that copper out of its place. Try the next one. On this next one, we need to change something. Bromine is a halogen, and so halogens are going to have a negative charge to them. So they're only going to replace the other negative ion. And so with bromine, we would want to look at maybe bromine replacing iodine. Magnesium has a positive charge, so it's not going to replace the positively charged ion. So if you look at bromine over here, bromine is higher up than iodine, so it is going to replace the iodine in a reaction. All right, so we're going to do a couple of practice ones together. I apologize, when transferring this PowerPoint, it turned my arrows here into squares, so I did draw them in here. So with the first one, the first thing I like to do is put in what the charges are. So chlorine has a negative charge to it. Zinc has a positive 2 charge to it. I know this because I've got 2 chlorines right here in order to balance with that zinc. Potassium, if I look on the periodic table, potassium has a positive charge. So my positive anion here, I'm looking on my reactivity chart to see if that positive anion will replace zinc. And if I look on my activity series, potassium is higher than zinc, so I am going to get a chemical reaction there. Chlorine on the next one has a negative charge. Hydrogen has a positive charge. Fluorine has a negative charge to it. For chlorine, if I look at chlorine, it is a halogen. And so I'm looking to see if the negatively charged anion, will the chlorine replace the fluorine for this one. So chlorine has a negative charge, fluorine has a negative charge. I have to look at my halogens activity series. And chlorine is below fluorine, so I'm actually going to get no reaction happening here. Aluminum, here I have aluminum metal, and I have tin and nitrate. And if I look at my activity series, I'm going to see that aluminum is quite a bit higher, and so the reaction will occur. Again, I want to make sure that my compounds are going to be neutral, so I like to write the positive and negative charges of each of those before I continue once I've determined if the reaction will occur or not. So take a second, pause the video, see if you can write out the proper compounds. The proper compounds should look like this. For the first one, you should have potassium chloride and zinc. Again, potassium positive charge, chlorine negative charge, so they balance out. On the last one, aluminum has a positive 3 charge with the nitrite having a negative charge. So I'm going to need 3 of those nitrites there in order for this compound of aluminum nitrates to be balanced, and then I have my tin. Now, lead. So now the last thing that you need to do is to balance the overall reaction. So that means you need to have an equal number of each atom on each side of your reaction. So pause the video here, take a minute. My suggestion is I write out each of my elements like this. Potassium, zinc, chlorine on one side, potassium, zinc, chlorine on the other side. I make sure and I first do an overall count of my atoms on each side. With my initial count, I have 1 potassium to 1 potassium, 1 zinc to 1 zinc, 2 chlorines to 1 chlorine, and now I need to balance. Pause the video and try to balance. And here's your first balanced reaction. You're going to need a 2 in front of the potassium here, and you're going to need a 2 in front of the potassium chloride. Go ahead and try to balance the third equation. Again, I usually write out each of my elements and start with how many of each do I have on each side, writing them in the same order, and then working my way to getting balanced. So this is the properly balanced reaction. You can see my work down here of aluminum having 2 on each side, the lead having 3 on each side, nitrogen having 6, and oxygen having 18. So you should have put a 2 in front of aluminum, a 3 in front of lead, a 2 in front of aluminum here, and a 3 in front of lead. If you did not get that properly balanced, I would suggest starting on a sheet of loose leaf paper with the original reaction and trying to balance it again on your own, pausing the video here. With a double replacement reaction, we're actually going to have the exchange of ions between two of the compounds. So if you look at my example down here, I have calcium hydroxide and I have hydrochloric acid. So we have two different compounds. So we're going to have the positive and negative ions of the two elements switch places. So if I write this out, calcium hydroxide, I have to first properly balance it. So calcium has a positive charge to it. Calcium has a positive 2 charge to it. Hydroxide has a negative charge. So a properly balanced compound is going to be CaOH, and I need 2 hydroxides to balance with that. Hydrochloric acid, naming acids, don't forget, if it starts with the word hydro, then it's going to be just a 2-element acid, so it's going to be hydrogen and chlorine. Hydrogen has a positive charge to it. Chlorine has a negative charge to it, so the proper compound for hydrochloric acid is simply HCl. Now, with a double replacement reaction, we're going to have each of the ions exchanging with one another. So in this double replacement reaction, hydrogen and chlorine are going to switch places. So my new compound that's going to be in my products is going to be calcium chloride, and calcium has that positive 2 charge. Chlorine has a negative charge, so I do need to still make sure that my compound is neutral. So my compound formula is actually going to be CaCl2, and then I'm going to have hydrogen with the hydroxide, and that actually forms water. So this is something right here that you should start to recognize, that instead of writing hydrogen with a hydroxide, I'm just going to write H2O. So that's going to be water there. Now the last thing I need to do is I have to balance my overall reaction. You can see I've already got a 2 here helping me with the balancing. That was because of how the PowerPoint transferred over. So in order to finish out this balancing, all I need to do is put a 2 in front of the H2O. I've got 4 hydrogens on each side, 1 calcium on each side, and 2 chlorines on each side, and 2 oxygens, so I am balanced. Go ahead and pause the video here. Try the next one on your own. And again, it's starting to be balanced for you because you've already got the 2 in front, but what we have is sodium hydroxide. Sodium has a positive charge, hydroxide has a negative charge, so the compound is just NaOH. And then copper, remember that the 2 here means it's got a positive 2 charge to it. Chlorine has a negative charge to it. So my compound for copper 2 chloride is going to be CuCl2. Go ahead, try the reaction and try to balance it on your own. Pause the video here. So here's your first step. Your 2 compounds should be sodium chloride. Notice that I have positive and negative written down here. My overall formula is balanced with that. And then copper hydroxide. Copper has a positive 2 charge. Hydroxide has a negative charge. So that's why I'm going to need 2 hydroxides to make my overall formula neutral. And now I can go ahead and balance my overall equation. In order to balance it, all I need is a 2 in front of the sodium chloride in my products. So now I have 2 sodiums on each side, 2 chlorines on each side, 1 copper on each side, 2 oxygens and 2 hydrogens, and so my overall reaction is balanced. The next thing we need to look at when we're doing a double replacement reaction is to determine if there is actually a precipitate that forms during the chemical reaction. A precipitate is simply a solid. And in order to figure out if a solid is made, we're going to have to look at our solubility chart. So this is how you read your solubility chart. What you need to do is determine which one is going to create the solid. The word soluble means that it's going to dissolve in a liquid. So that one is not going to create the precipitate. The word insoluble means that it does not mix or dissolve in the liquid. So the ones that are insoluble are the ones that are going to create a precipitate or a solid. And so if I'm looking at my two compounds that I have up at the top, I have aluminum nitrate. And so I look down and I find aluminum right here at the top of the chart, and I find nitrate, and I read across until I reach aluminum, and it says that it is soluble. So that means it's going to dissolve in the liquid. That means it's not going to be the precipitate. It is not going to be the solid. It's going to be the liquid portion of the reaction. It is soluble. It's going to dissolve in the liquid. If I look at the other compound and I look at lead chlorate, okay, I find lead right here, and I find chlorine right here, lead chloride, and I go across, it says insoluble. There's actually a mistake in here. So this is insoluble, which means that it is going to form the precipitate, or it's going to have, this one is going to be the solid form. So I would mark this one here as aqueous. This is going to be the liquid, and I would mark this one here as my solid. So in a double replacement reaction, there's always going to be one of three things produced. You're going to produce either water, a precipitate, or a gas. So here's an example for you. I've got potassium cyanide. The chemical formula for potassium cyanide is going to be KCN. Potassium has a positive charge, cyanide has a negative charge. And I'm going to take potassium cyanide and I'm going to react it with hydrochloric acid. I'm sorry, that's a typo. This should be hydrobromic acid. So I'm going to have HBr for my hydrobromic acid. That's an acid, so it's aqueous. And with a double replacement reaction, my positive ion is going to replace my positive ion. So what I'm going to have happen here is I'm going to have these two positive ions switch places with one another. And so my new products for my chemical reaction is going to be potassium and bromine reacting with or making a compound, the second compound. The second compound will be hydrocyanic acid. And so if I look on my solubility chart, I will find that potassium bromide is aqueous, so I'm going to write aqueous there, which means that I then look up hydrogen cyanide, and it is not a solid, which means that it is a gas, must be a gas, because I have to either have water, a precipitate, or a gas. I don't have water, I don't have a precipitate, therefore the hydrocyanic acid must be a gas. This is actually a very important thing that you're going to need to remember with double replacements. Today in class we just identified if there was a precipitate or not. If there is no precipitate, if none of them are a solid, the next step is to look and see, is either one of them water? If not, then it must be a gas, and we need to write that in parentheses here. So if the ions do not form the precipitate, they simply remain dissolved in the solution. So that would be the aqueous compound that is there. Or again, remember, we might form a water or we might form a gas. So either we have to get a solid precipitate, water, or a gas. One of those three things must form in a double replacement reaction. So we have a couple of practice problems for you. I have lithium iodide reacting with silver nitrate. Now, again, in class today, we practiced where first thing is write down your charges on each of your elements. So I've started with doing that. This is a double replacement reaction, so I'm going to have my positive cations replace one another. So when they replace each other, I end up with silver iodide and lithium nitrate. The next step is to make sure my chemical reaction is balanced, which it is, and then finally to look at my solubility chart. If I look at silver and iodine, I see that it is insoluble, so it's going to form a solid. So I'm going to put an S here. It's going to form a solid, okay? And that means that my other compound here is going to be dissolved. So that's going to be the liquid part. Try the next one on your own. This is a word equation, so you're going to need to make sure that everything is balanced in the end and that each of your compounds is neutral. Pause the video here and try that on your own. So your final reaction should look like what I wrote in red here. Barium chloride aqueous reacting with potassium carbonate. If I look at barium carbonate on my solubility chart, I do see that it is insoluble in water. So this one is going to be, that's going to be my precipitate. That's going to be my solid that forms. And then potassium chloride is going to be aqueous. It's going to be soluble in the water. It's going to be dissolved, or the liquid that is there. Make sure to try to practice the rest of the problems on the worksheet we were working on today. It will help you prepare for the test. And if you have questions or you want to sit down for some tutoring, please come in to see myself or Mr. Dittmeyer.